So I'm gonna talk about autonomous vehicles in general. You can call them CAVs, AVs, connected vehicles. I'm sure Kate spoke a lot about that earlier. And I'm gonna focus primarily on highway asset management. So as autonomous vehicles technology is perfected and improved, and deployed out in our cities, in our highways, driverless vehicles will face another big hurdle, and that hurdle is probably going to be the existing built environment. Given that the current roads, intersections, all of our signage, road markings have been built to accommodate human drivers, pedestrians, cyclists, and the related infrastructure, as well as its maintenance, will need to adapt to make it safer for all road users in the future, for road users and and all the modes. The extent to which autonomous vehicles therefore will create a new set of maintenance issues, needs, requirements for road authorities to undertake, which will require funding as it is today. So improving the existing road infrastructure to better accommodate autonomous technology, as I said, it poses significant costs, which is already challenging for relevant authorities as they struggle already to upkeep the maintenance of the infrastructure. And also at the same time, must keep in mind that the available budgets, either from central government or raised locally, is declining for most actors within the asset management game. And also, of course, at the same time, there is the continuously evolving and the uncertain technological landscape. A lot of answers to asset management will be given as the technology is improved and perfected. It's going to give us a lot of answers, as with many things surrounding autonomous vehicles. So I'm going to start with a few of the basic implications for asset management on highway asset management. So the greatest demand on road infrastructure will arise from fully autonomous vehicles sharing roads with vehicles with partial or no automation. So we are probably going to be seeing a mix of different levels of automation sharing this road at the same time. So it raises the question whether we should be segregating AVs at the start and maybe removing the segregation. This is partially answered by where you actually deploy the autonomous vehicles, whether it's highway or urban setting. So this mixed traffic might lead to the retention of all current safety infrastructure and the possible addition of new infrastructure required by automated systems. In other cases, it might make sense to have CAV designed lanes, as we said, or entirely segregated roads for autonomous vehicles, which of course will be very, very expensive and also raise many planning and safety issues. The design of the road network will also need to take into account the increased risk to other road users arising from a more complex road environment. So unless autonomous vehicles are to operate on completely separated, dedicated infrastructure, other road users will need to be separated or at least educated to change their behavior or nudged to change their behavior and adapt to how CAVs operate in our roads. This might translate to new types of guardrailing, more bridges or underpasses, and an increased need to, of course, maintain these assets to a high degree. And even the simple behavior of crossing the road, it might change in the future with the associated changes in road management and maintenance. And as far as we know right now, the industry is, the autonomous vehicles industry, we know that communications is the most important aspect of autonomous capabilities. So it becomes the most important asset class when it comes to asset management. And by communication, I mean communication infrastructure. It might be roadside cabinets containing beacons, sensors, and it might also be fiber optic connectivity. And so these assets is what creates the connectivity, what connects the infrastructure to the vehicles and vehicles to vehicles potentially, and of course aids in enables the navigation of each car. So this asset class that will it will require extensive development and of course new asset management methods. So also, and careful thought would also need to be given to the issue of driving in degraded conditions, including those arising from severe weather, road accidents, or emergency situations that require maintenance. And so, for example, one problematic situation would be the case of roadworks, where localized lane markings may disappear or be replaced by new ones, or even cones, temporary cones or temporary lane markings. So there is, or even the usual way where traffic is guided through the roadworks by staff using hand signals or signage or handheld signs. So how would autonomous vehicles deal with that? Now, moving specifically into specific impacts on the road infrastructure, signage and lane markings is it can go either way. It's the lane keeping assist systems, which are now the feature of many cars, even standard cars, are reliant most of the times on road markings to accurately determine the boundaries of lanes. So this implies that these markings therefore need to be maintained in good condition at all times for the automated systems to work. For example, asset management will need to ensure that markings and signage remain visible also for all road users. However, as the levels of automation increase, delineation, as in markings, road markings, might become less important. As communication networks, what I referred to earlier, as communication networks start to wirelessly provide all the information required for the vehicle to know where it is. In any case, until fully autonomous vehicles are commonplace, the maintenance standards and needs will need to be enhanced, updated, and of course aligned with the technology as the systems evolve. And the next one is street lighting. There will be perhaps more stricter requirements to ensure visibility of road markings, as in light, in terms of light, or reflective. And it's not just the visibility of the markings, but it's also visibility of the car, so that the car can see traffic lights, for example. So there might be situations where we need to install multiple sets of traffic lights at particular locations so that all cars can see the traffic lights. And moving on to the rutting of the asphalt, there will be, because autonomous vehicles will run consistently in the same lane positions, for example, if you're platooning, there will be greater wear and tear on where the wheel tracks frequently run. So it means that either the area beneath these tracks will need to be strengthened, or maintenance repairs will need to be more frequent. Although after speaking to a few to programmers, to technical companies around involved into AV's research, they told me that they can actually program the cars to run slightly left or slightly right to the vehicle ahead. So my point is that technology can overcome some of these potential issues. And drainage is something that is quite important with autonomous vehicles and maintenance. It is currently uncertain how autonomous vehicles will perceive things such as surface water, localized flooding, even though the reactions of autonomous vehicles to events such as skidding or aquaplaning may be better than those of human drivers. So better design and improved maintenance of highway drainage is likely to be crucial. Essentially, autonomous vehicles, the radars, the lidars on board the car, they don't like standing water. It reflects the rays back into the car and loses some of these navigational capabilities. And planning for roadworks, that's another strand of research that is not yet resolved. Because, for example, in London, if you are a utility company and you want to do roadworks, you have to apply, get a license, and so that traffic management systems know that this link, this road, this stretch of road is off limits. There is no traffic traveling on that stretch of road, so you reallocate the traffic. So autonomous vehicles, they will require very detailed, up-to-date maps of the routes being traveled. So it might be, as I said, the case of London, of how the utility companies submit for roadworks, it might need to be implemented at the national level, for example, this database that's updated in real time and shared, propagated in real time, the information. The last possible impact is road verges. It's a geotechnical feature that might need to be adapted in the future so that autonomous vehicles operate safely by ensuring that the onboard sensors, some of the onboard sensors, which depend on a line of sight, can operate effectively. So poor management of verges could diminish both the observation of other vehicles and also the verges themselves might play a bit of havoc with the vehicle positioning because the vehicle can't see ahead. So for example, there might be need to better control vegetation clearing to ensure good visibility. And it's not just a question of how autonomous vehicles can, the question we need to ask also is how can autonomous vehicles help with asset management? The technology opens up a few more opportunities, exciting opportunities that can enhance actually asset management and even make it cheaper in the long term. So autonomous vehicles, especially as connectivity increases and they become smarter and smarter, they will be generating and collecting a lot more information than they do now. So we can know even today the condition of the road surface, location of dangers on the road networks, for example, location of potholes. All of these will be prerequisites to the safe and efficient operation of autonomous vehicles. So the data collected by autonomous vehicles in terms of road condition, it will not only aid in the navigation and routing, but also make asset management more efficient by enabling a data-driven, proactive asset management. This enables a targeted approach, meaning that maintenance teams can target specific assets or specific locations that require the maintenance most, and not simply react when a pothole just appears. However, saying that, we can do this even today. You can take a Mercedes S-Class, drive it all over any road you want, and you can collect gigabytes of data, how far the suspension traveled, and you can know that there's a pothole here, for example. Now, the problem still remains that the local authority, even if you identify every single pothole in a county, they don't have the money to fix it. So we are actually giving them an extra headache at the moment. I'm about to show you also a video, a very interesting initiative by Colas, which shows how to utilize current commercially available technology to improve and make highway asset management safer.
Colas are global innovators and they invest heavily in research and development.
One thing that's come out of innovation is road worker safety. Originally, a few years ago, we used to have 3 guys putting out traffic management in one IPV. We've reduced that to 2 being protected because we brought in another impact protection vehicle, but the person driving the impact protection, he was at risk still.
This autonomous IPV project removes that person altogether, therefore there's zero harm should the vehicle be struck by a member of the public.
The system uses an electronic breadcrumb system, leader-follower system. So as soon as the lead vehicle takes off, it's laying down a trail of electronic breadcrumbs. My vehicle then will aim for the first breadcrumb. When it gets to that point, there'll be a slight left-right correction on the steering wheel, and I know then that the vehicle is fully autonomous and has picked up the trail. It will follow at the same speed with the set gap, and it will change lanes left or right with the lead vehicle. It will mimic their speed, it will accelerate at the point that they accelerated, and it will brake at the point they braked. It will also constantly monitor the gap, so if they've accelerated harder, it will notice that the gap's bigger and it would start to accelerate prior to where that accelerated just to close the gap, and the same with the braking system as well.
We've done over 150 hours of driving, and in that we have covered a distance in excess of 1,000 miles. We have also trialled it on the M3 under closed carriageway situations to see how it would adapt to actual live carriageway road markings, and all of the testing to date has been extremely positive.
So what is the future for this? Well, within Colas, we really want this to be the industry standard whenever impact protection vehicles are working out on the live carriageway.
By the way, the same technology is also used in the military in a few other applications, but again, it's existing technology, and that's what I really like about this idea. So to conclude, it is clear from the limited research and understanding of CAV technology as the technology advances, is that autonomous vehicles and existing road infrastructure and future infrastructure exist in a reciprocal relationship. How this relationship will develop is uncertain at the moment, and at the same time we must be humble and embrace the uncertainty. And at the moment, the relationship is driven by technology, and I hope that, and probably it's going to be shaped later on by policy and standards around asset management. Now, autonomous vehicles or connected and autonomous vehicles penetration rates and mixed traffic operation is a key issue. Depending on the rate of penetration of cars into the markets, there's a possibility of roads being shared by vehicles, as we said, of varying degrees of automation. Now, this situation would lead to the retention of all current safety infrastructure, but also with the possible addition of new infrastructure required by automated systems. For example, the communication infrastructure. We are not always talking about physical hard structures here. And this is quite critical also, is about the experience from other sectors. What can they teach us? So experience in aviation has suggested that the approach to maintenance has to change as automation increases and maintenance costs typically increase. This is partly because the infrastructure has to be better maintained for safety reasons, safety critical reasons, and partly because it becomes more sophisticated, meaning that the maintenance workforce has to be also upskilled and therefore, they charge more for their services, so it costs more for the maintenance. There is quite a few academic articles written around this relationship between technology and maintenance as the technology improves. But how are we going to finance and save and make maintenance in the future? How to make it sustainable? So how can we create a financially sustainable and safe road network, properly maintained for all future users? So I will point you to the direction of the Wilson Economics Prize, that it had exactly the same theme: how to provide for the future, suitable road network, and most probably road pricing is also part of the solution. So, thank you very much.
Thank you.